Hello, in this video, we're going to talk about coordinate geometry. So I'm going to break down this entire topic into four parts. So you can see here that I broke it down into gradient, length, and some concepts to do with straight line graphs, as well as some geometric problems that you're probably going to see involving some coordinates. So I will go through some examples, or actually I'll go through one example that illustrate all four of these concepts. But before that, let's briefly talk about what each of these concepts entail. Okay, so the idea behind coordinate geometry. So when you see the word coordinate, what you think of is kind of like drawing graphs, right? So you think of things like your y-axis, x-axis, and then you have like points, okay? Points. For example, this point is maybe described as 2, 1. Sorry, 1, 2, okay? Because I drew it like this. So 1, 2. Okay, so for example, like this. So this bracket with 1, 2 inside, this is called a coordinate. And what a coordinate is, okay, I want you to think of coordinate as like a kind of like an address, right? Kind of an address, okay, that describes where a point is in space with respect to the origin, okay? So basically, it's just describing points in space, points in your 2D XY plane. Now, coordinate geometry, okay, we are going to use these different like kind of like addresses of points to study things like shapes, things like lines, right? How they are how they are spaced out in space. Maybe for example, let's say I have 2 points, okay, 2 points and if I join them, I get a line segment, okay, that goes kind of, okay, I'm just gonna put inverted commas direction, okay? So this so-called direction is what we call the gradient of the line segment, right? So let's say I have another 2 more points, and then I realize that, hey, look, they kind of look like they are going in a so-called same direction. We say that they have the same gradient, right? And what if we join, let's say, these two, right? We get something. Okay, let's make it a little bit different. Let's say this bottom line is a bit shorter. Let's say we join the points and we get something called a trapezium that you should have learned before in your topic on polygons, quadrilaterals, right? So coordinate geometry makes use of coordinates, okay, a coordinate system, and it allows us to study some objects in geometry, right? Things like shapes, things like lines, okay? So what these four concepts, okay, that we need to know entail, I will go through very, very briefly because these concepts are not too difficult, and I want to very quickly go through these concepts before we go on to one example question where we go through how to use these different concepts to solve problems. Okay, so the first one is gradient. So gradient is kind of like the direction or the slope, right? So the direction, or you can think of it as the slope of a line segment. Okay, so notice that I keep saying line segment instead of just line. In math, usually when we say line, it goes on forever. Things like your line graph, right? Your y equals mx plus c. The line goes on forever. But when we say line segment, there's a start and an end. For example, there's a start point A to point B. This is line segment AB. For example, there's a line segment PQ. Okay, there's an end. Okay, so how do we find the gradient of some line segments? Okay, to find the gradient, okay, let me just quickly kind of rearrange these things a little bit. So how we find a gradient? Gradient is given by, let me just write in yellow. Gradient is given by y1 minus y2 over x1 minus x2. Okay, so how this works is just, actually, if you want to think about it, this is just rise over run. Okay, rise over run. So what is rise? Rise is just, how if you walk from P to Q, you rise or you gain some height, okay, equivalent to what the difference between the y-intercepts are. The y coordinates are. So let's say this is x1, y1, and let's say q is described by x2, y2. Okay, so the rise is simply y2 minus y1. Okay, which is slightly different from what I wrote down, but I will explain later why this doesn't really matter and this actually works. Okay, so the rise is y2 minus y1 because you know that y2 is the bigger number, right? Okay, now your run, run. So run is just, in a sense, kind of like you read from left to right. So in math, you kind of, in a sense, walk from left to right. And, okay, the run is basically how many units you walk, right, in front or left to right. So in this case, your run is x2 minus x1. Okay, x2 minus x1. So how do I know it's x2 minus x1? Because I know that x2 is a bigger number, right? Based on how I drew these points, I know that x2 is a bigger number than x1. Okay, but I'm going to say that this actually doesn't matter. It doesn't matter which number is bigger or smaller. So let's use this other example. Line segment AB. Okay, so remember that we said that our gradient is given by rise over run. So in this case, right, our run from A to B is forwards, right, from left to right. Okay, so let's say A, let me give them some coordinates first. Okay, my iPad's asking me to sleep. Let's ignore that. Okay, so let's say A is given by coordinates x1, y1. B is given by coordinates x2, y2. Okay, basically they're just numbers, but you know that from left to right, x1 and x2, x1 is on the left, x2 is on the right, which means x2 is a bigger number or a more positive number, right? So based on kind of like, I'm sure you guys have like drawn quite a lot of graphs. You kind of know left to right is getting bigger and bigger or more positive. Bottom to top is getting bigger and bigger or more and more positive, right? So run in this case is given by y2 minus y1 because y2 is the bigger number. Now your rise is not actually a rise, right? It's actually going downwards. It's a down slope, right? Because in math we kind of always read from left to right, so we kind of walk downwards from A to B. So our rise is not actually a rise, right? It's actually just going downwards. I don't know what words to use, okay? But so the idea, behind this is that we're still going to use so we're going to still use the word rise to describe this, but we have to keep in mind that this is down slope lah. Okay, down slope. Sorry, I just realized that I made a mistake here. It's not supposed to be y2 and y1. It's supposed to be x2 and y1, x1. x2 and x1. Okay, my bad. Okay, so for the green arrow, we're going downwards. In this case, right, we are walking from A to B. So let's use y2 minus y1. Okay, and you will realize that y2, is a smaller number because this is the y coordinate. So the higher up is a bigger number. Lower down here is a smaller number. So y2 minus y1 is a small number minus a big number. That's negative number. That's why my arrow is pointing downwards. Okay, and if you want to do a bit of exploring, you can go and sub in some different numbers. Maybe you can even try to swap it around. Instead of y2 minus y1, you change it to y1 minus y2, x1 minus x2, right? It doesn't matter. It doesn't matter, okay? Whether you do y1 minus y2, x1 minus y, sorry, basically 1 minus 2 or 2 minus 1, okay? It doesn't matter. You still get the same gradient, okay? Which means as long as we pick a direction to walk, okay, a direction to walk, that means either from A to B or B to A, P to Q or Q to P, okay, the formula here, okay, the formula here will handle whatever it is on their own. Okay, you don't need to bother checking like, oh, should it be left to right, right to left, bigger number minus smaller number or whatever. Doesn't matter at all. Okay, doesn't matter at all. So you just need to remember this formula, okay, y1 minus y2, x1 minus x2, or swap it around, y2 minus y1, x2 minus x1. Okay, just make sure that, okay, one important thing is make sure that this comes from the same point, this comes from the same point. Okay, so pick one point to write down first, pick the other point to write down later, and remember it's always rise over run, vertical over horizontal, and that's it, okay, for gradient. Okay, length. Okay, length is length for the formula. Okay, let me just write it down first. The formula is square root. Okay, square root. Now inside is going to be y1 minus y2 squared plus x1 minus x2 squared, whole thing square root. Okay, so you might think that there's a bit of similarity, but the similarity is just y1 minus y2, right? x1 minus x2. Okay, actually length is much easier to understand, I feel. Okay, so we're going to use the same, let's use AB. Okay, so let me just write it down like this. So AB, I'm going to draw a right angled triangle. So AB over here, let's call the coordinates x1, y1, okay, x2, y2. Now, the length we are concerned with, we can use Pythagoras theorem. Okay, the length is given by, let's say we call the length L, okay, L. So L squared equals to this part, okay, or let's call it A. Okay, let's not call it A because we called the capital letter A at this point. Let's call it some other letter. Let's call it maybe let's say, what letter shall I use? Let's say M and N, okay? Okay, M and N is quite difficult to pronounce. Let's call it S and T, okay, S and T, okay? So let's call it S and T. So L squared is equals to S squared plus T squared. But what is S? S is just the difference between the Y values. Okay, T is just the difference between the X values. And remember that from before, we have just written down y2 minus y1, and y2 minus y1, x2 minus x1, x2 minus x1, right? So we just need to sub those in, and then to find the length, we're just going to take square root. So let me just take square root here. Okay, let me just take square root here. By right, okay, by right, I need to, oops, wrote a bit too long. Okay, by right, I need to take, put plus minus, right? But in this case, we know we are going to find length, and length cannot be negative. So we're just going to delete, we're just going to not write down the plus minus, okay? But if you do feel safer, actually I do feel safer if I write down plus minus, then I reject the negative symbol or the negative version. But it's not required lah. It's not required, okay? But if you want to do it, by all means, it's not wrong. Okay, actually it's more correct if you do that. But anyway, if you memorize this formula, then you don't have to do that. Okay, so actually this formula I don't have to really go and write this down again. It's over here. Square root of the difference in the y value squared plus difference in the x values squared, then cover the square root. Okay, so I'm gonna make this a bit smaller again. This formula is just given by Pythagoras theorem. So if you can, okay, and I really encourage this, okay, if you can, try to sketch out what the situation looks like, okay, what the diagram looks like. So that will be quite important because it helps you visualize, perhaps it helps you in the next two parts, or maybe actually the last part, I think. Okay, now third concept, straight line graph. Okay, so why did I just write down straight line graph here? Actually, it's a bit more. Okay, straight line graph, and you're gonna talk about how to interpret the straight line graph, as well as how to find the straight line graph. Okay, so what do I mean by these two? Okay, let me just use a bit more space down here. Okay, so let me just maybe use red color and point it down here. Okay, so for straight line graph, how can I interpret the straight line graph? Okay, this is quite simple. First of all, let's write down what we know of the straight line graph equation. So that's y equals mx plus c, right? So m, okay, let me just annotate here. M is your gradient of the line. Okay, c is your y-intercept. Okay, now just to do a quick little recap. Okay, what kind of gradients are there? So a gradient of a line, okay, gradient, okay, it's a bit too dark. Let me use green. Okay, gradient, okay, gradient is kind of the slope, right? So we're going to think of it as up slope, okay, or up, kind of like left to right up slope, down slope, flat ground, and then vertical, like kind of like a wall. So when gradient is up slope, we say that m is more than 0. So it's a positive slope. Okay, that means you are going up a hill. When you're going down a hill, m is less than 0. Okay, it's going downhill. But when you're on a flat ground, your gradient is 0. And what happens when it's 0? When it's 0, basically this entire term, m equals to 0. So 0 times x. So we don't have anything here, right? 0. So what is left is y equals to c. Y equals to c. Which means y equals to c gives you the equation of a horizontal line. Okay? Now for the last scenario, we have a vertical line. And this vertical line is when m is undefined. Okay, you can, if you want to, you can think of it as infinite gradient. Okay, that means kind of like without walking in front at all, you're going straight up and down, right? Infinite gradient. But that's not technically correct lah. Okay, so by right we're supposed to say undefined. Okay, if I don't know if the question, if any scenario where you have to talk about what this kind of vertical line, what kind of gradient it has, you say undefined. Okay, don't say infinite gradient. That's actually incorrect. Okay, so this is quite a short recap of what gradient, what types of gradients there are. Okay, so I'm just going to make this a bit smaller and put it aside. Okay, so I'm gonna put it here. Right now, let's come back to this straight line graph equation. Okay, so sometimes we might be asked to interpret these straight line graph equations, right? So what do I mean by interpret? Let's give an example. Let's say I have y equals to 2x and y equals to 2x minus 3. What can you describe? What can you say about these two lines? I can say that they have the same gradient. Okay, and what does same gradient mean? Same gradient, different. If you want, you can add on different y-intercepts. Okay, but I don't think it's that important. The important part is that they have the same gradient, and therefore they are parallel lines. Right? Parallel lines. Okay, so I think this is quite important to know that you know, if you have the same gradient, that means two lines are parallel. Okay, now what about things like your y equals to, just y equals to 2. So like we mentioned just now, there's no x term here, which means in this case, your gradient, okay, gradient is 0. Okay, rather let's write m equals 0. Okay, so it's horizontal line. Okay, then if you have x equals to some number, x equals to, for example, -3, okay, this has undefined gradient. Okay, undefined gradient. And what does undefined gradient mean? It means you have a vertical line. Okay, so these are a few types of things that you need to know how to describe. And I don't think there's much else for this. Okay, but of course, if you see questions, sometimes they might ask you to apply your knowledge a bit more creatively lah. Okay, but this is, I would say, is pretty much what you need to know to interpret the equation of a straight line. Okay, basically it's just this kind of equation, y equals mx plus c. Okay, what can you tell from this equation? The idea is you can tell the gradient and the y-intercept. But of course, you can take it a bit more, you can take it a step further, and you can talk about how lines with the same gradient are parallel, or lines with some special gradients, maybe 0 or undefined. Those are some special lines like horizontal, vertical, right? Yeah. Okay, second thing, okay, let me maybe, okay, I'll put this in a bit smaller, maybe at the side here. Okay, now second thing, let me write in green. Okay, what else do we need to know? We also need to know how to find a straight line graph, a straight line equation, right? A straight line graph equation. So how can we find a straight line graph equation from 2 points? Let's say I have 2 points given. A, maybe okay, I'll just give numbers. Okay, I'll just give number. Maybe 0, 3. Okay, let's not use 0. 1, 3. Okay, and then maybe, sorry, cannot erase. Okay, and maybe B is 6, 5. Okay, how can I find a line that passes through these 2 points? First of all, I need to find a gradient, right? So I need to apply what I learned just now. I need to find a gradient. So how do I find a gradient, right? The gradient is, I'm going to do it like this. So I'm going to use maybe A first. But instead of writing, okay, so I'm going to write a fraction, and then something minus something, something minus something. I'm going to put brackets. So what these brackets are is kind of like a fill in the blanks, right? I just need to plug in some numbers. So what I'm going to do is I'm going to take this y value, put it on top, x value, put it below. Why? Okay, the reason why I put the y value on top and x value below is because gradient is rise over run. It has to do with vertical over horizontal. Okay, next one. So I have B. Vertical component, sorry, not vertical component. Y component is 5. X component is 6. Now this entire thing I can count by hand. If you want to, you can, but be very careful. If not, you can type into the calculator. Eventually you should get 2 over 5. Negative 2 over negative 5. Yes, 2 over 5. Okay, so I have the gradient. Now what do I need to do? I put it into y equals mx plus c, but I'm going to sub in A. Okay, maybe I'll use purple to sub in. Okay, I'm going to sub in A. So I'm going to say y, which is 3, equals to gradient, which is 2 over 5, times x value, which is 1, plus c. So how do I find c? I just need to rearrange. Okay, I just need to expand this first or multiply this first. 2 over 5 times 1, that's equals to 2 over 5. Then C is, okay, this one I need to move it to the other side of the equation. So eventually, if you do a bit of working, you get C, okay, C equals to 13 over 5. Okay, 13 over 5. So C equals 13 over 5. Now what do? I put it back into y equals to mx plus c, but m is 2 over 5. X plus c. C is 13 over 5. Technically, this is correct already, right? This is correct already. But what can I do to make it nicer? Okay, let me change this to green. Okay, what can I do to make this nicer, right? Maybe I don't like to see too many fractions. I realize that the denominator are both 5. Okay, multiply by 5 throughout to get 5y equals to 2x plus 13. Okay, so I'll prefer to write it like this so that I don't see too many fractions, but either way, the answer is correct. Okay, let me also again make this a bit smaller so that it doesn't look too messy. Okay. Alright, so that's for straight line graph. Okay, straight line graph. Last one, geometric problems involving coordinates. This one is a bit tougher to explain without an example at hand. Okay, so geometric problems involving coordinates basically is just asking you to talk about shapes. Okay, things like your trapezium, things like parallelogram, rhombus, right? Squares, rectangles, right-angled triangles. Okay, usually some of these are easier 3 and 4-sided shapes. So usually these geometric problems involving coordinates, what you need to solve them are two things. Okay, actually 3 things. Let me just list out 3 things to be a bit more specific. First thing is you need your gradient, right? Because you want to talk about things like parallel lines, right? Or parallel lines or non-parallel lines. Okay, usually the parallel part is a bit more important. If it's not parallel, then I mean, sometimes we might be asked to show that it's not parallel, but I don't think it's that common. Okay, so one thing is gradient. Second thing might be length, right? For example, things like rhombus. Rhombus is kind of like a slanted square. So all its sides have the same length. Maybe your rectangle or your parallelogram, opposite sides have the same length, right? So length can be quite important in geometric problems involving coordinates. Now last thing might be wondering, like, what else is there, right? Other than these two, straight line doesn't really seem that related to shapes. Okay, the last one is actually just knowledge about polygons or shapes, right? So actually not really polygons, more of knowledge about triangles and quadrilaterals. Usually is these two lah. Usually is 3 and 4-sided shapes. Okay. I haven't really seen any coordinate geometry problems in N level that have to do with shapes with more sides. Okay, usually it's 3 or 4 sides. So this last concept, I'm not going to really spend too much time here. I want to go on to a concrete problem to solve, mainly because this last thing is about geometric problems, right? We can't talk about problems just by talking about what kind of problems they are, right? We want to solve some problems to take a look at how these problems can be approached. So let's look at one full problem, one full question. Okay, so I purposely didn't include a sketch here, so I want you to think along with me. Okay, if you want to try, you can pause the video and then try to imagine, or okay, not imagine, try to really go and sketch it out, right? Go and maybe sketch out y and x axis, try to agar-agar, right? Roughly go and sketch out where are these points. It doesn't have to be exact, it doesn't even have to be like really nice or whatever, right? Just roughly have an idea of how these points are placed, right? Are they in a sense, let me just quickly draw out something. So y-axis, x-axis, are they maybe one above the other, right? In a vertical arrangement, or are they maybe horizontal? Maybe one is here and one is here, right? Or how else? Or maybe are they on the x-axis, or maybe this side of the x-axis, or are they at the positive y-axis or negative y-axis? Are they maybe even at the origin, right? So you want to sketch it out to at least have a good idea, have a good visual, right, on how these points are placed near each other or around each other. When you have this diagram, okay, or when you have this image, it can be much easier to approach your problem, right? Because if you can tell where the points are, it's much easier to tell, like, okay, I expect the gradient to be maybe less than 0, maybe it's downhill, right, downslope, which means if I calculate and I get a positive number, I need to reassess, right? Is it because my sketch is wrong, or is it because I used the wrong formula, or is it because I typed in the calculator wrongly, or whatever it is, right? Check your answers, right? So you have some sort of reference. Okay, so now I'm going to try to do this, okay, without really sketching out the thing very nicely, okay? So I'm going to pretend like I'm during the exam, right? I'm under a bit of stress. I don't really have the time, or really don't really have the focus to go and like sketch out very nicely lah. Okay, so I'm just gonna anyhow sketch these 3 points. Okay, so what I'm gonna do is like this. So I'm gonna sketch out my y and x axis. Maybe I sketch very small. Maybe I don't have much space on my exam paper. Okay, of course I will recommend that you sketch out not too big. Okay, not too big. Don't take up too much space, but also try to make it like a big enough for you to see very clearly lah. So of course you don't go and draw until super small, and then then you can't even see what you're writing, right? There's no point. Might as well don't sketch. So draw maybe 1/4 of the space you have, or maybe a bit smaller than that. I don't know. Okay, it's up to you. Okay, so what I'm gonna do is I'm going to use yellow as to plot the points, and I'm not going to plot them very nicely. Okay, first thing I'm gonna notice is that A has the same y coordinate. So what does that mean? That means they are probably gonna, not probably, but they are going to lie on the same height, in a sense, your same y value, same height. Okay, and it's going to be y equals to 1. I don't care whether y equals to 1 looks something like this. Okay, I'm just going to treat it as that's y equals 1. So I'm going to put A over here. I'm going to put B over here. Okay, so B over here. Now next point. C is 6,8. Now 6,8, I realized that, oh crap, right? I drew everything up here. All this space is wasted because C is like above, right? So how? Never mind. Again, same thing, right? I mentioned that I want to draw as if I'm doing it in the exam, right? I don't have the luxury of like using my iPad to rearrange some stuff. So I'm just gonna leave this like leave the diagram like this. I'm gonna put C, maybe should be up here somewhere. Okay, should be up here somewhere. Although maybe it's not exactly there, but it doesn't matter. Okay, how do I know it's here and not somewhere else, right? How do I know it's here? Or how do I know it's roughly somewhere here? I know that the x value for C, 6, is smaller than B, 8. So it should be somewhere in between here, right? So C should be somewhere in between here. And I also know that the y value for C is bigger than A and B. So it should be higher up. So I guess it's somewhere there. Okay. Now, I can go on to part A. Find the length of line segment BC. To find the length of line segment BC, okay, maybe I'll write my answer in yellow. You know what? I'll put everything in that I'll write down in yellow lah. Okay, except maybe the axis so that it's not so confusing. Okay, so part A. Find the length of BC. Length of BC, right? So how do I find the length of BC? I remember that length of BC is something to do with Pythagoras theorem, right? Pythagoras theorem. So to find BC, okay, I need this and this. In a sense, the rise and the run, right? So I know that rise and run is basically just the y value minus each other, the x value minus each other, right? So I'm going to take BC, right? B first, then C. So B. The y value of B is 1. Okay, so 1 minus something squared plus x value 8 minus something squared. I'm going to put a square root first, okay, so that I don't forget. And I realize that if I put plus minus also can, but I'm going to reject the minus. So I realize that, okay, in that case, no point because I can just use this as a formula. Alright, so x coordinate. I must remember that this is y and this is x. So maybe I go and put down, maybe I write down here, this is y, this is x, right? Actually, if I want to make it a bit nicer, this is delta y, delta x. Okay, the triangle symbol is delta. It just means change in y, change in x. So y1 minus y2, x1 minus x2. Okay, so change in y is 1 minus the other y value, which is 8. Change in x is 8 minus 6. Okay, let me just quickly draw arrows to see where I put the numbers from, then I'll erase them. So y1 minus y2, y1 minus y2. Okay, x1 minus x2, x1 minus x2. Okay, so now I'm going to erase them. Okay, so that it's not too confusing. This one, if you type into the calculator, you will get your answer. Let me just quickly calculate it by hand. This is 49 plus 4. Okay, this is square root of 53. And it should be like this. I don't think you can simplify this. So 53. Okay, next part. Find the gradient of line segment BC. So almost the same kind of difficulty, right? So this one you can just use the formula gradient of BC. Gradient of BC is given as y1 minus y2 over x1 minus x2. Now remember, y1 and x1 must come from the same point, y2 and x2 must come from the same point. Okay, so what I'm going to do is I'm going to erase. I'm going to put brackets. This is what I usually do in exam. Okay, so what I'm going to do is I'm going to take B, okay, because BC, right? So easier to just take B first. B, I'm going to copy down the y and x value. Y is 1, x is 8. So I'm going to write down y is 1, x is 8. I'm going to take C. C is y is 8, x is 6. So 8, 6. Now if I go and calculate this, of course you can use your calculator. This will be negative 7 over 2. Okay, negative 7 over 2. Done. Okay. Part C. Find the equation of the line going through points B and C. Okay, B and C. Okay, so we know that the gradient, of BC is negative 7 over 2. We're going to write down y equals mx plus c first. So what we're going to do is we're going to sub in the gradient, which is negative 7 over 2. The y and x, I'm going to put brackets, and I want to find c. Okay, I want to find c. So what do I sub in for the x and y? Okay, what I'm going to do is I'm going to take the coordinates of B and sub in. So coordinates of B is 1, 8. Okay, so this is the y coordinate of B. This is the x coordinate of B. Okay, what I'm going to do is I'm going to put down here a note for yourself, okay, to try using coordinates of C and try. It should give you the same exact answer, okay, and the reason why is just because what we are doing is we are going to just make use of the fact that B lies on this line, which means I can sub in the coordinates of B and nothing will go wrong lah, basically. Okay, basically the coordinates of B agrees with this equation. Okay, now that I've substitute all the numbers in, I just need to solve for what? Solve for C. So what I do is I'm just going to evaluate this part first. So what I get is 1 equals to negative 7 times 8 divided by 2. So that's negative 28. Okay, plus C. So C is equals to 29. Okay, so C is equals to 29, but that's not the question, right? The question is asking for the straight line equation that's passing through B and C. So therefore, equation of line, okay, usually you just write down in your answer the answer blank. This is y equals to negative 7 over 2, which is the gradient, times x plus 29. Okay, so this is the equation. Okay, part D. Okay, let's scroll back up to look at part D. Part D is given ABCD is a parallelogram. Find the coordinates of D. This one is it might be a bit hard or harder, okay? But the idea is just that ABCD is a parallelogram. We have ABC. So given that it's a parallelogram, we're going to draw a parallelogram first. Parallelogram. So it looks like this. D should be somewhere here. Now what do we know about parallelogram? AB parallel to DC. That's one thing. Okay, we're going to write it down. AB is parallel to DC. What else? Second thing. AD parallel to BC. What else? We also know length of AD is equals to length of BC. Okay, when we write these two capital letters, right, side by side, AD, it means length. Okay, or if you're uncomfortable with that, you can write one of two ways. You can write the absolute value, it just means length, or you can just write length of AD. Okay, spell it out. Okay, but it doesn't really matter. Okay, AD equals to BC. We also have, last one, AB equals to DC. So we have quite a lot of properties that we know about a parallelogram. So we're going to use, I think, two of these, right? Two of these. You can choose which one you want to use. But I think I'm going to use the parallel ones, right? Actually, let me scroll back up to copy the coordinates. Okay, let me just duplicate this and bring it down so we can refer. Okay, so I have all these. Okay, I have all this info. Let me use the first two. Okay, let me use the first two. So first one, AB is parallel to DC. So what does this mean? This means that gradient of AB, okay, gradient of AB must be equals to gradient of DC. Okay, what is gradient of AB? I think I found it at the start. Oh, sorry, that's BC. Okay, that's negative 7 over 2. Okay, in that case, let me write that down first. AD parallel to BC, which means gradient of AD equals to gradient of BC. And gradient of BC is -7/2. Okay, the rest we haven't found, but we can find them quite easily using the formula lah. Okay, so gradient of AB, I'm going to write down the big fraction, bracket minus bracket, bracket minus bracket. Then I'm going to fill in the blanks. A first on the left side. Okay, I'm going to fill in the y and then the x. So y over x. Second one is B, y over x. Done. Okay, type into calculator, you get the answer. Gradient of DC. Well, we don't know what the coordinates of D are. That's exactly what we're trying to find. So what I'm going to do is I'm going to actually, forgot to write this down, but I'm going to actually write let coordinates of D be x, y. So I'm going to say that we let it be x, y, and what we want to do is want to find what is x, what is y, right? So same thing, okay, gradient of DC. So I'm gonna put a big fraction, bracket minus bracket, bracket minus bracket. Okay, for D, we're just gonna sub in x and y. We're gonna pretend like those are numbers, right? So y over x. C is 8/6. So okay, let me actually move this one down a little bit, and we can have more space to calculate our answer. So the first one, gradient of AB, 0, right? Because the top is 0, the denominator doesn't really matter. 0 equals to y minus 8, x minus 6. Now realize that, hey, if this is 0 and this is equal to some fraction, right? The denominator doesn't actually matter. As long as the top is 0, the numerator is 0, the equation holds. That means y minus 8 equals to 0. And y is equals to 8. Okay, so I found y. Now we're going to do the next step. Gradient of AD, we're going to put a big fraction again, bracket minus bracket, bracket minus bracket. For A, okay, I'm going to sub in here, A, 1 and -2. 1, -2. For D, instead of y and x, I'm going to sub in 8 and x. Because I just found what is y, right? So I might as well use it. So now I just need to clean this up. I need to evaluate maybe the top is -7, the bottom is -2 minus x. Equals to -7/2. Okay, I'm going to put this negative sign on top. Okay, actually I'm going to write it as -7 whole thing over 2. It'll be a bit easier. So what I'm going to do is I'm going to, okay, this is an equation. I'm going to divide by -7 on both sides. So divide by -7 on both sides, I get 1 over -2 minus x equals to 1/2. Now I'm going to, okay, be careful about calling it cross multiplication. Okay, what I'm going to do is I'm going to take one of the denominator, multiply on both sides. Then, okay, so I'm going to do this. So multiply the denominator on both sides. Okay, multiply the denominator on both sides. Then again, I take the other denominator, multiply on both sides. Okay, so you can see the both denominators I multiply. Take two denominators, multiply on both sides. So now I'm going to cancel. I'm going to simplify the fraction. I see the same factor on top and below, I can cancel. See the same factor on top and below, I can cancel. And what I have left is, on the left hand side I have 2 times 1, 2. Right hand side I have 1 times that bracket, so -2 minus x. I want to find what is x, so I'm going to add x on both sides, so plus x plus x. So x will appear here, plus 2 equals to -2. Now I can straight away -2 minus 2, so I get x equals to -4. Okay, so x equals to -4, which means we have found our coordinates of point D. Because I let coordinates of point D be x, comma, y. And we have found our x value, we have found our y value. So I can just say that, therefore, coordinates of D is -4, 8. And I'm done. Okay. Of course, we have done a simple sketch beforehand, right? So I'm going to remember this, -4, 8. I'm going to scroll back up to look at my rough sketch here. Does it look legit? Does it look real, right? So I said that D is -4, 8. Now let's check. AB is horizontal, right? It's horizontal, it's the same height. Which means CD should be the same height as well. And I realized that D has a y coordinate of 8, C has a y coordinate of 8. Seems correct, right? Or at least up till now is correct. Now, x coordinate of D is -4. D should be around here, should be like on the left side of x. On the left side of A. A has an x coordinate of -2. From here, from what I found, D has an x coordinate of -4. Is to the left. Seems correct. Okay? So unless I'm very unlucky, or unless I was very careless, okay, maybe I made a mistake in my calculations. If not, everything seems to check out. So I have checked my answers. I think that everything is correct here, and I can call it a day, move on to the next question. Okay, so yeah, that's all I have for this video. Yep, see you.